Welcome back, everyone. My name is Tim Coates, and I'm going to be presenting a video lecture here on programming with selection structures. And we're using Microsoft Small Basic. And this particular video, we're going to be building several examples, and I'm going to illustrate basically how to get a computer program to make a decision. So, making decisions. Now, usually in a program, when the program needs to make a decision, it's for one of two reasons. Either the user has entered something and they are selecting a menu option, or they're clicking on a button or whatever, and the computer has to choose a direction to go in the program. So it could go down a certain road. You can almost think of it as you have three roads facing you, and which one do you go down? Well, in order to figure out which road to go down, you have to ask a question. So the question can be obtained from the user, or it could be some other programmatic test of some kind. Like, for instance, has the character bumped into the wall, if say it's a video game. So there's a question, or you could also refer to it as a test. There's some test that you're running, or you're evaluating some sort of a condition. Now, the word condition is what the book uses and what most programmers use to refer to this test that I'm talking about. A condition is either true or false. And the condition must be built with code. So here's an example of a condition, right? Age is greater than 65. That's an example of a condition. Again, it's either true or false. Now, when you're dealing with decision-making structures, what you do is you put this condition inside of parentheses like this, and then in front of it you put the word if. On the other side you put the word then, and you put an end if down below. And the way this is going to work is it will ask the question if age is greater than 65, and if it's true, it runs the code. In this case, whatever would be on lines 11 and 12, it would run, and then it would reach line 13, and it would just continue on from there. Now, if the condition happens to be false, then what happens is the program skips over lines 11 and 12 and essentially jumps over to line 13 and then just continues on. So this particular construct is called a single alternative structure. Well, single alternative decision structure, if you want to be complete about this thing. It only has one of two paths to go. It's either going to run the code inside of here, or it's not. Now, there's another type of structure called a dual alternative decision structure, and that's where you actually have two different paths that can run. An example of this would be if age is greater than 65, then else, and then an end if. Now, the difference between the two, in this structure right here, if the age is greater than 65, it's going to run a certain block of code, and that's it. If the user's not, if age is not greater than 65, it's not going to do anything. But down here in this structure, if the age is greater than 65, it's going to do whatever's in block A, else it's going to do whatever is in block B. Now if I come back up here and I put the same letter structures in. So this structure right here, okay? Let's just say age is equal to 60. So age being 60, then the question is what is the path that the program is going to take? Well, it's not going to take and run line 14, which is A. It's only going to run C, which comes after the end if statement. If the age is, let's say, 70, if it's 70, then 70 is greater than 65. So it's going to run the code inside of the block here. So it's going to run A, and then it's going to reach the end if, and it's going to run C. So whether the condition is true or false, it's always going to run C. The only issue here is whether or not it's going to run A. And that's where we get the single alternative. It's either going to run A or it's not going to run A. Now, if I use the same logic down here, and say the age is 60, the path, okay, what path would it take? Well, is 60 greater than 65? No, it's not. So it's not going to execute this portion of the block, but it will come down to the else portion and run that. So you'll end up running B, and then you hit the end if, and then below that you have C, and it will run C. But if the age is equal to 70, 70 is greater than 65, so it will start by running A, and then it will run C. Now again, like the example above it, you're always going to be running the code represented by C. And that's because C there is it's below the if block. The if block starts at line 20 and ends at line 24, this highlighted block. So whatever happens in here, it's always going to run what comes next, which is line 25. Same thing up here. Here's my end if, or my if block. Whatever happens here, whether it runs it or not, it'll come down and always do C. So whether or not it runs C is not an issue. It will always do C. The question is simply what happens before that. Like in this case here, does it run A or does it not? In this case down here, does it run A or does it run B? It has to run one or the other. There is no middle ground here. Now let me show you one more variation on this type of structure. And I'm going to put some separators in here just so that we don't get confused with where we're at. Okay, so looking at this third block here, let's take a look at what the code is going to do. The test, there's actually two tests, right? Up in these other cases, there was only one test. Now we have two actual tests that are running. The first test is a single alternative. It's if age is greater than 65. If it is, do A. If it's not, there's no other alternative. Then you have this part of the block, which is a dual alternative structure. Another question is introduced. If age is greater than 10, then do B, otherwise do C. So you can combine single and dual alternative decision structures together in ways like this. And what this is doing, say the age of the person is 60, well, it's going to run, since 60 is not greater than 65, it's not going to run A, but then it'll come down and say else if is age, I'm going to make that less than 10 instead of greater, is age less than 10. Now because it's 60, that is also false. So the only thing left is to run C, which it will always do, and then it'll also run D at the end. Now what if the age is somewhere in the middle, say it's 30? 30. Is 30 greater than 65? No. Is 30 less than 10? No. Else it'll run C and then D. What if age is equal to 80? Well, 80 is greater than 65, so it will run the A branch. Now once it executes a branch, and this is important to understand this, once it executes a branch, or in other words, once it goes down a road, it doesn't go down any of the other ones. So what we mean by that is this. Age is equal to 80. That's greater than 65. So this test passes. So the condition is true. And it runs this block of code here. It will jump all the way down to the end if after it runs block A. It will not check line 29. And it will not go to the else. So you can only go down one path, A, B, or C. The first two cases it went down path C. If age is 80, it goes down path A. Well, if the age is 8, it's not greater than 65, so it will not do A, but it is less than 10, so it will do line B. It'll disregard everything else till it reaches the end if, and then it will continue along and do block D. So you can see here, it's always going to do two things, either A, B, or C, and then always D. So this example may be a situation where you're asking a customer's age and you might give them a discount. So let's say they're greater than 65, you might give them a 80% discount, say on a meal. In this case here, I gotta make this look nice all the way through, so make this B, give, we'll say free meal. So if they're less than 10, they get a free meal. And if they're C, charge regular price. So something like that may be a good example of where you would use a structure like this. And obviously there are literally a huge number of variations that you could apply here, and it just completely depends on the problem that you're trying to solve. So the best way to learn this stuff is to just get lots of practice. You can look at some examples and they'll make sense to you, but it isn't until you really dig in and write some code that this stuff will start to click and you'll be able to use all the different variations of what's out there. But just knowing what we know now, I'm going to switch here over here to a small basic, and I'm going to do the code that we just put into our little text document. And so I'm going to go in and just do this the small basic way. So what we're going to do is we're going to ask the program here to ask the user, what is the customer's age? Now we're going to set age equal to text window dot read number. So we have our age. Now we're going to say if the age is, and I have to switch back over to my document to see what we did here. So if I want to go for the gusto and do this bottom one, so if age is greater than 65, then I'm going to take one particular path. I'll just put a comment there for now. Else if age is less than 10, then I'm going to do the second path. Else, now you'll notice that the environment's fighting me a little bit. It expects me to fill the code in as I'm going down. And what I'm doing here is I'm just sort of setting up the framework. I'm not putting any code in other than those little comments, those A and B comments. So you can see it's fighting me just a little bit. Okay. This is going to seem a little bit odd when you first look at it. It isn't really working yet. I just wanted to make sure it would run. There is no space between the else and the if. This is all one word. And this and if, there's no space in there either. Now, some versions of BASIC want the space and others don't. So it can be a little bit frustrating to know what to put there. But for you all, since you're first starting out, not so much, but just remember not to put a space in between the else and the if. Now, if you put a space there, the error that you'll get is unexpected token if found on line 7. And in English, what that means is you can't put the space between the else and the if. Now, another thing, you don't have to put the parentheses in to the condition. I've kind of gotten into the habit of doing that because most languages out there require it, but BASIC is one of the ones that does not. So I could come in here and take that out. And it makes the code a little bit more readable, maybe a little bit less cryptic. People will disagree on that and say, well, the parentheses draw attention to the condition and they separate it out from the rest of the code, but whatever, it's just a convention issue. In this particular case, either way is fine, but you don't have to put the parentheses, and most small BASIC examples that you'll see out there do not, so I'm not going to put the parentheses in there either. So that's our program. So then what I'm going to do is, if age is 65, I'm going to give them a 80% discount, which means I'll just say 0.8 for 80%. If they're less than 10, really they get a 100% discount. And if they're not either of those, they get a 0% discount. The meal cost, we could prompt for that also. We could say, what is the cost of the meal? Again, I'll put read number. And then I'll put cost equals Now if I take cost and multiply by the discount, so if you think about this, if the user gets 80% off, now if the meal costs $10 and you multiply 10 by 0.8, you're going to get $8. If the meal costs $10 and the discount is 1, it's going to stay the same, so I don't want that to happen. I need to switch these two numbers around. If the age is less than 10, I want to give them a free meal, so 0. So I'd be 10 times 0 would be 0, the cost would be 0. If discount is 1, 10 times 1 is 1. Essentially, it's unchanged, but I've got all three cases in here. I'll put a comment, 80% discount, 100% or free meal, and then no discount. Now I need to set those, I need to set discount every time because I'm multiplying by it on line 16. So it has to be set to something. And so that makes it work out. And then I can say to the text window, the cost of the meal is $ plus cost. And then in running it, so if the customer is 50 and the meal costs $10, then the meal is $10. You don't get a discount. If the customer's age is 5 and the meal costs $10, then the cost goes to 0. And if the customer is 80, the meal is $10, then the cost of the meal is reduced down to $8. Now you might be wondering about this 8.0 and how do I get that looking nicer so that it says 8.00, and we'll talk about that here in a bit if we have some time in this video, but for now we need to get through this loop. Through this loops are next time. The selection structure stuff, I want to make sure we get through that first, so we'll save that for a little bit later on. But this program, I'm going to save this and stick it out in Blackboard for you so that you can take a look at it if you'd like. I'm going to call it Selection Example 1, and I'll save it. So there's our first example, and at the top I'll put a comment here. And I'll just put a simple little description. I won't get too fancy for this. I'll just so hopefully that makes sense to you. I'm going to save this, and I think what I'm going to do here is move on to another video section, a part 2, so that these videos don't get too long. So I'm going to do that and close this video off. So jump on over to part 2 and we'll continue out with this. So we'll see you in the next part.